So we're going to talk about things that are integers and things that are not integers. But we're not going to be super strict about what is an integer or what isn't. There might be a question on a learning goal somewhere. Circle which ones are integers. This is a strict definition. This is something that in other courses and as you proceed through math, if you take it like moving on into higher level math, it's definitely important. We're talking about it because we're talking about integers, but we'll end up maybe using a looser definition of what an integer means throughout the course. Mara, did you want to ask something? Okay. So what is an integer? Somebody name an integer.
Integer. Negative numbers.
So give me a negative number.
-1, -2.
Anybody else?
-5.
-5. What about positive numbers? Are they integers? So somebody name a positive number. Alex?
Positive 5, 6,
7? How? Yep.
Positive
8? What about a million? Let's be creative here. Here's a tricky one. Is that an integer? Well, it's equal to 2. 4 divided by 2 is 2. So in the form that it's in, it's actually not an integer because integers are not fractions. Integers are not fractions or decimals, but that's a tricky one. Again, I'm never going to try to trick you and ask if that's an integer or not for marks. But, there is that. What are things, so I just said decimals and fractions are not integers. So name some things, give me some examples of things that are not integers. And this is not, there's no trick to this, just name some random decimals or fractions.
1.5.
Love it. 6 over 6 would be 1. So how about 6 over 10? Yep. Which you could reduce, but we're not going to worry about that. That's okay. Okay. But like, folks, we can do anything. -7.2. Oh, it's negative. Isn't that an integer? Well, no, not technically, because integers are not decimals. That's a different kind of number. It may seem weird to you, but it's a different kind of number. This is 0.6, right? So again, it's a decimal, so not an integer. What about this? What's that number?
Pi.
It's pi. And pi is an even different kind of number because it never ends and never repeats, so it's definitely not an integer. What if we had something like 0.3 repeated, which is 1/3? So it's a decimal. It's a repeating decimal. It can be written as a fraction. Pi cannot be written as a fraction. That's why it's a special number. So not an integer. Or, yeah, not an integer. You want to give us one more?
Okay.
2.111111211 a million times or something like that. Yeah, that's a good one. So you could get creative. That's not the point of this. But what things are integers, what things aren't. So integers don't have decimals and no fractions. Integers are positive and negative whole numbers. I forgot, whoops, that you studied this last year. Is that right? Yeah, a little bit, not a ton, but a little bit. So we didn't used to in this new course that you took, that you were the first people taking it last year. You did a little bit of work on this. You talked about whole numbers, natural numbers, integers, rational numbers, and then real numbers. You probably didn't talk about imaginary numbers. Did they ever mention imaginary numbers? So there are more kinds of numbers beyond what you looked at. But I think you probably went all the way up to rational and irrational numbers. Pi is an irrational number. It's definitely not an integer. So you talked about this. So you would have done more of this last year than we're going to do. That's all we're really worried about. The reason why I say this is, could there be a decimal or a fraction in this integer math that we're doing? Yeah, there could. We're not doing fractions yet, but decimals are kind of up for grabs because we can just use our calculator. So like when we say integers, we mean whole numbers, which means no fractions, no decimals. And we mean positive and negative. But, you might see the odd decimal pop up here or there or something like that, okay? When we talk about multiplying and dividing integers, what we really mean is, well, now we're talking about negative numbers as well. The nice thing is the multiplying and dividing, this is good for a Friday because it's fairly straightforward. And I would break it into two parts. Remember we talked about this yesterday when we did substitution, that when you start to get harder questions, if you can split it up into parts, sometimes they call that chunking. If you can split it up into parts, it makes the question easier. So this is how I do it. Two separate parts. Multiply or divide the numbers normally. If you can do this in your head, that's fantastic. If you can't, use your calculator. What is 5 times 8? 40. 5 times 8. If I was using my calculator, I would probably put the negative in there. But this is what I said yesterday. You're going to struggle if you can't do simple integer math in your head. So I would challenge you to try right now over the next few days. Try doing some of it in your head. If you have to check on your calculator, do it. Step 2, use the rule, which is this rule over here, to find the sign of the result. 2 positives makes a positive. 2 negatives makes a positive. Positive and negative is, and negative and positive is. In other words, if the signs are the same, it's positive. If the signs are different, it's negative. When the questions get a little bit harder, we're going to have to extend that rule. But that's the first step. So this is positive, this is negative. The signs are different, so our result should be negative. Good, very good. So we should get negative 40. Doesn't matter what order you do it in. 2 negatives makes a positive. So this answer is going to be positive. 9 divided by 3? 3. Or just 3, because we don't have to use the positive symbol when it's positive. Again, we've talked about this already. 2 things beside each other in brackets like that means multiply. So this is, again, 2 negatives makes, and 8 times 3 is? Good. Not so bad? Negative 8 times negative 3, positive 24. Or, if you're even more confused, you could just type it out the exact way it says on the sheet with these calculators that we have, and it's so easy and it just gives you the answer. But again, I would caution you to just use the calculator for all of this, because there are skills coming in grade 10 academic that require you to have mental math abilities. You can't use your calculator for them. Not really. It would take a long time. So I would caution you on that, and I would strongly recommend that you try to do some of this mental math in your head. At least understand that two negatives makes a positive, or a positive and a negative makes a negative. At least know that rule. If you have to do the multiplying on your calculator, then that's what's going to happen. Okay, on the back. What happens when it's 3? So we could do this one at a time, and some of you were doing this when we were doing bed mass and substitution, and that there's not a problem with that, especially if you get, as long as you're getting the right answer and you're just showing extra steps, that's totally fine. But I'm again going to challenge you to try to do it in one step, and this is how it works. I would do a positive times a negative. What would that give me?
Negative.
So that would be negative, and then I take that result, negative times negative, and that's going to give me a.
Positive.
So I'm going to get a positive for this question. 4 times 3
Oh.
times 2,
24.
24. Four times negative 3 times negative 2, positive 24. This question had two negatives, so they cancel out to a positive, and the result is positive. A negative times a positive is? Negative times positive is? So this result is going to be negative. It only has one negative, so the result is going to be negative. Anybody noticing a pattern here? We'll get to it after the next few. 1 times 5?
5.
5 times 6? 30. Okay, this one's got division for the first time, but division follows the same rules as multiplying. So negative and negative makes a?
Positive.
Positive and negative makes a?
Negative.
So the result is going to be negative. So we had two negatives that canceled together to be a positive. We had one negative, so the result is going to be negative. If you add in adding and subtracting or exponents or anything like that, then these rules go out the window, right? This is just for multiplying and dividing. And then we had two negatives which canceled to a positive, but then we had a third negative. So what's the rule here? If you, what if you had 4 negatives? 2 would become positive, 2 would become positive, and then you'd have positive. So if you have an even number of negatives, you know what I mean by even number? 2, 4, 6, 8, 10. You're never going to multiply 10 things in a row, I don't think. But 2, 4, 6, 8, whatever, it's just one page up. Will cancel out in pairs. Cancel out in pairs to be positive. But if you have 5 negatives, 2 will become positive, 2 will become positive, you got 1 left over. So the result is negative. So that's a rule that you can use to quickly determine when you're multiplying or dividing a bunch of things together, whether the result, the final result, will be positive or negative. But again, you can also use your calculator. 4 times 5?
20.
20. 20 divided by 2?
10.
Very good. So negative 10.
Thank you.
Well, this one's easy. It's funny how we start to get confused when we add in negatives to questions and people start to overthink things and they're like negative. No! This is a question that you would have done like back in grade 5 or 6 when you didn't even know about integers and negative numbers. They're all positive. The result's going to be positive. Right? This one's a bit harder. 3 times 4?
12.
12 times 5. Anybody know that one? That's a tricky one. Okay, good.
Yeah.
You're going to say 60? So it is 60, but this is where maybe you go, you know what? I want to check that. Okay, 60. Or do the whole thing, 3 times 4 times 5. What about this one? It's 3 times 4 times 5 again. Very good. Why negative? Can you explain? odd number of negative signs. That's right. There's 3 negative signs. So 2 will cancel out to positives, and you have 1 left over. Nice. Last one looks like a doozy. There's 4 in there. Those 2 become positive together. These 2 become positive together. So it's going to be positive. 5 times 1. 5 times 2.
10,
10 times 6.
60.
So it's 60 again for a different reason, but positive. How do you feel about that? Not too bad, right? Not too bad. Multiplying big numbers gets hard. We got calculators for that. But that rule, and then extending it to more than just 2 numbers, is the big takeaway from this. And then the last thing we're going to do is talk about exponents. And exponents can be tricky, in particular when integers are involved. So we're going to look at 4 examples to compare all the different situations that you can have. Notice that they're all look like -5. 2 of them are squared, 2 of them are cubed, or degree, or to the exponent of 3. -5 squared, what do you think it is?
Negative. Positive 25.
So positive 25. Well, the 25 part is right. Let's see what the calculator says. Why is it negative? Why is it negative? It's negative because when there are no brackets, the difference between these 2 is when there are no brackets, it means this. So it means 5 squared, which is 25, and the negative stays out in front. Whereas this one means you're including the negative when you multiply it twice, because it's in the brackets with it. This is going to be an important concept moving forward, and again, like I've been saying, into grade 10, because there are different kinds of questions that are a lot harder than this, where you have to know that property, that whatever's in the brackets gets multiplied through. If it's not in the brackets, it's like this. Okay? So 2 negatives makes a positive, and 5 times 5 is obviously still 25. So the difference here is this is -5 cubed. What's 5 cubed? Well, that might be too hard to do. So 5 cubed, this has a cubed button. Or 5 to the exponent of 3. The button on this calculator is that one. I hope you can see that. X to the box. Okay, and again, 125. But I know that the answer should be negative, so negative 125. And this is -5. Hold on, times -5. When I write it out, I got 3 negatives. So the result is negative, because the first 2 cancel out to be positive, and then you have 1 negative left over like we did in the previous example, and then 5 times 5 times 5 is still 125. Now take a look at these 4 cases all together. These 2 kind of go together, and those 2 kind of go together. And we can build a rule, and the rule is written below. When you have if the base of your exponent is not in brackets, so that's the first one and the third one, the result's always negative, because the negative is not being multiplied through. If the negative is in the base, if the exponent is even, the result's going to be positive, because you're going to have an even number of negatives. If the exponent is odd, like the 3, the last example, then the result is negative, because you're going to have them pair off and have 1 left over. Do you have to know this rule? If you're using your calculator and doing it properly, I guess not. But sometimes we type things into the calculator wrong, and if you don't understand the answer and you're just writing it down blindly, you're not going to catch your mistakes. So my recommendation is use your calculator, that's fine. But if you punch it in, you're like, wait a minute, negative? That answer shouldn't be negative. Why is that answer negative? It should be positive. You'll catch those mistakes. Do you know what I mean? So watch. When I typed in -5 squared, if I meant to be doing this one, I get the wrong answer. What I meant was, the calculator knows the rule too. But the calculator is only going to answer what you ask it to answer. So if you don't type it right, it's not going to give you the right answer. So brackets can be picky. All right, try that one. At least get the sign, if you can use that rule. And if you don't know what 3 to the 4 is because you don't have a calculator in front of you right now. And if you don't have a calculator, just grab one when you walk in. Okay, so you have it on your desk. 3 to the 4, or 3 times 3 times 3 times 3. That's 3 plus 3 plus 3 plus 3.
Oh.
What's the sign? Let's do the sign first. What, the sign's going to be positive y? And it's in brackets. Right? It's in brackets and it's an even number, so it's going to be positive. Very good. And what is 3 to the 4? 81. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. That, again, I think we had this one the other day. And that's getting to be bigger numbers. Okay, try the next one. Don't shout anything out because I want everybody to be able to think it through.
Can I change my account? Can I grab
Yeah,
one of
yep,
those?
absolutely. So based on the rule, what's the sign? Right. It's going to be negative because it's outside the brackets. And why might somebody think it would be positive? Yep.
That's an even number on its own.
Because the exponent is even, so when you square it, you would get 2 negatives makes it positive, but the negative is not in brackets. If the negative was in brackets, it would be positive, not in brackets, so negative and 8 times 8. Yep. Oh, didn't have your hand up. Go for it.
81.
Huh?
81.
Mm-hmm.
Negative 64.
64, negative 64, very good.
Um,
You think of 9 times 9.
yeah.
That's okay. Well, there's no trick to this one. There's no negative in it. So what's the result going to be? Yeah, good. But positive, right? Like it's going to be positive no matter what because there's no negative involved. So 4 times 4 times 4 is 64. Very good. And what about this last one? Don't shut it out, please.
Negative 390.
So again, 7 cubed, can you do that in your head? Oh, probably not, right? So 7 times 7 times 7, 343. Very good. Any questions about that?